I'm going to play with the pixel processor in Substance Designer 6. First thing I need to do is get a new substance, and I'll go with physically based metallic roughness, although I could go with empty, but I'll go with this one. Now I want to get this guy here, this pixel processor. So if I click it, then that node is put there, and I will edit it. I was just thinking for a minute whether I wanted to do grayscale or color, but I think I'm going to leave it in color. And so now we're inside of it. And what this does is whatever the graph is that you create here, even if it's a graph of one node like this one here, which is a constant, that gets applied to every pixel. And that's it. So at the moment, what's getting applied to every pixel is 0, 0, 0, 1, which is, of course, RGB alpha normalized to 0 to 1 space. So if we look at the slider for red, there's that. Green. Put them both high, you get yellow. And alpha kind of operates as you can see it's going back down toward that transparency checkerboard. So let's get rid of this and let's make something of our own. First of all, let's read in a let's just play within the pixel processor for a moment. So if I say what I want to do is I want to get the address of every pixel. So I need to say spacebar float to, because what the addresses are, they're stored in floating point numbers between 0 and 1 for U and 0 and 1 for V. Origin up in the corner. So now that we have this, actually, I'm going to set that aside. That's not what we want. We don't want the constant. We want to say get float to. Now that's the same thing. It's a float to. But if we double click on this and come over here, we can see there are a few system variables that are available. One is size log 2, and pause for position. I'm going to ignore these for the time being and just go with pause. So what this does is it basically gives you the UV coordinates of the image that we're in. Even though we haven't read in an image, it has a kind of a virtual image that's 1024 by 1024 because of the substance. So if we say, for example, float, no, to vector float 2. Okay, there we go. So if we put this here, and see, it's a little bit confusing because you got to get the type right. So pause is what we need to do is I'm thrashing around a little bit here. One of the things that I could do is I could swizzle it out into floats. Let me just show you what that looks like for a second. Swizzle. And then Control D for duplicate. Another swizzle. And this one we're going to set to Y. And then that can be fed into there like that. And then we can say, we could take another one of these. Here's vector float 4. So here's a vector float 2 going in. I'm leaving these two unattended. And I'm going to right click on that and set as output node. So here, actually, let me not do that. I'm going to say constant float and Control D. And this guy, Control D, and we'll put that there, and that there, and then this can go into the other two slots. And then if we move this 0, that's our blue, I believe, and that's our alpha. That's why we're not seeing anything, because the alpha was 0. So if we take our blue back down to 0, and let me just set it to exactly 0. So you can see here's, these are the values coming from position X and position Y, which are going through the red and green channels. 0, 0 up here, and yellow down here, red here, green here. Kind of a typical UV image, except possibly upside down from the way you're used to using it, depending on what software you're using. So now what we can do is let's play around a little bit. So let's say that let's use that to address an image. So we'll come up outside of the pixel processor, and we will get a bitmap from file, and I'll just read in picture I have sitting around on my hard drive, and I'm just going to say link resource. It's a mannequin. I put it in there. We go back into the pixel processor, edit, hit that button. So now if we say that we're sampling this, let's take these and set them over here. And let's take these and set them over here. And now if we say sample, this is how we sample color. This is how we get our images to come in. So right now you can see it's green, sort of cyan. See, is this the same type? Yes, it is. Okay, it's a little hard to see. So if we take our numbers and we set this to our output node, then there's our picture that we're reading in. So really all we're doing now is we're taking the values from that are the pixel coordinates. We're explicitly putting them into an X and a Y. We're regathering them into a float 2, and we are sticking them into this sampler thing here. So it's a little bit of a roundabout thing, not entirely necessary, but I want to show you how to then sort of play around and get independent control over these two things. Let's play around with the indexing of this image. So first thing we want to do is let's try, right now the indexes go from 0 to 1 and 0 to 1. What would happen if we made them go from, say, 0 to 50? So let's try making a float, and we'll put, for starters, we'll put 50 in it. And what we're going to do is this X, we're going to multiply by 50. And we'll multiply the Y by 50 as well. So here's the X times 50. Here's the Y times 50. We'll use the same 50. Why not? And now it's going between 0 and 50, but it can't go between 0 and 50. It has to go between 0 and 1. So let's try this. Let's take these indices, and let's use a function called floor. So right now, if you think about it, we're going from 0 to 50 through all the decimal places. So there's a 50, there's a 39.825, or there's a 12.763. And if we take these numbers and we floor them, which is to say we throw away the floating point component of them, So now we've done that. Now what we're going to do is we're going to subtract let's see, where's subtract? Let me just type in SU. There we go. Subtraction. So we're going to subtract the large number with the floating point minus the floor version of it. We'll do the same over here. The large number with the floating point minus the floor version of it. So now what we're left with is, instead of going all the way up to 50, we're going to go, every single number is going to be just, all that's going to be left is the floating points, but they're going to loop around 50 times. So if we take that and put it into here, and take that and put it into here, then if we play with this 50, so you can see what we've done is we've tiled it. And notice that we have, like right now it says 2.285, and this is 1, 2, and then 0.285 is that much. If I made this exactly 3.5, you have 1, 2, 3, and there's exactly half. 1, 2, 3, and there's exactly half. So what we're doing right now is we're controlling the tiling of an image, basically. I mean, there are other ways to do it. This isn't the easiest way to do it, but it kind of demonstrates the kind of control that you have within the pixel processor. Let's try something else. Let's try, instead of tiling it, let's try breaking it up into mosaic, blocky, like coarse pixels. So we take the same image. I'm going to just copy. I'm going to move this over to the side for a moment. I'm going to take this and I'm going to copy this over here, and I'm going to make this the output node for the time being, although these two things are identical, so you would never notice the difference. So now what I want to do is I want to take, let's try a number like just a bigger number so we can kind of see what we're doing. So let's try, what we want to do is we want to take these numbers and we want to multiply them. I'm going to make it a bigger number just because I'm going to make it like 35. All right. So now we take the address and we multiply it by a fairly large number like 35. And then what we want to do is we want to have only the floor. We don't want to have the floating point. So we don't need to do this anymore or this anymore. Here's the floor. Now what we need to do, now that we have numbers that go from 0 to 35, but they have no floating point component, they're only integer steps between 0 and 35. So now what we want to do is divide that back down, divide that back down by the same number. So if we've blown it up 35 times, we want to take this number with fractional steps and divide it by 35. I'm putting that in the denominator, presumably. And the 35 in the denominator, this in the numerator. Take this, put it here. Take this, put it here. Okay, there we go. So now if I take this 35 slider and I take it down now, this is a not a sophisticated way of doing this, because what I'm doing is I'm taking every 46th pixel and, you know, repeating it a certain number of times. I'm just throwing away. In other words, when you see a square here, it doesn't represent what the average value is underneath. It's just the first value repeated multiple times in both directions. But, you know, it's kind of good enough for certain applications. I always like it when a tutorial shows the ending first so that you know whether the whole rest of it is worth sitting through. And because I'm actually relatively new to Substance Designer, I kind of fumbling a little bit, although I think it's worth the trip. And I just want to show you what we're about to do. So if I take this number here and I play with it, you can see it changes the number of squares. And notice the way they change size too as they go. Now, if I put enough of them in, you can see that they're resolving into that mannequin. And if I play with brightness, you can see that I have different controls on it. And I could add more controls too, but I think this is kind of interesting. So that's what we're about to do. You'd be surprised that it's actually not that complicated. And hang in there, and I'll show you how it's done. Hope you like it. I like it when it's real abstract like this in the beginning. Okay, let's push a little further and see what we can do with what we're coming up with. I'm actually relatively new to this, so that's part of why I'm a little slow with it, but I've done this kind of thing enough times in other software that, you know, I can do the principles apply. So let's see, this guy down here, which we're currently looking at because he's orange, is the Mosaic. So I'm going to say add a frame. Okay, so we're going to call this one Mosaic. And we're going to call this upper one, add a frame. We'll give him a different color. We're going to call this one tiling. All right. Let's see, let me get rid of this and maybe bring this over to here. Okay, so now we have a little bit more room. Now, what I want to do is I want to go back up to outside of the pixel processor, and I'm going to try just changing it to grayscale. I see that it seems to have worked, so hopefully we're now able to continue in grayscale. And I would like to bring in a second image. So I have the first image, which is on my desktop, which I'm reading in. And now I want to read in a second image. And the second one is, I'm going to use the FX map. And I'm going to make it grayscale. And Control E. I'm going to make the pattern diamond. Where is it? Oh, pyramid, I think is what I want. Pyramid. Okay, that looks pretty good. So come back up here. Now here's my pyramid. And let's see. I want to read that in. So when I attached this image, there was only one input over here. And when I did attach it, it created a second input. And so there's that one right there. I'm going to try, let's see, grayscale, gradient map. Grayscale conversion, let's see. If I do that and that, just to kind of make sure. I'm kind of, like I said, I'm a little bit inexperienced with what using this, but so we go into it, edit. Now what I want to do is I want the mosaic to be this guy over here, and I want the, let's set this as output for the time being. I want the tiling, first of all, let's set this to a nice round number of 30. And let's set this guy to a nice round number of 30 as well. What I'm working on is a kind of a halftone effect, where the squares are going to be proportional in size to the brightness of the underlying image. So tiling, we're going to sample. Where's our sample? Here's our sample. So what we want to do here is we want to sample, we go to our sample node and we say input 1. You see it switched over to the diamonds. And the filtering nearest is fine. Maybe just for the heck of it I'll say bilinear, although this is a slower algorithm. And maybe this guy I'll also say bilinear, although it's really not necessary, probably considering how blocky we're making it. So now, let's see. What I want to do is I want to say float, and it's a 0. Control D. Where did that go? Actually not sure. There it is. Okay. 0 or 1. Now, that's going to be based on which one of these is brighter. And I haven't done this before, so I'm kind of experimenting right in front of you. So let's say if, and then we want to say greater than, because we want to test to see greater is fine. So if this, and I'm going to try something and it's either going to work or not, and I'm going to, if it doesn't work, I'm going to have to play around with it a little bit. Input, it's putting out those blue. I guess I'm not successfully switching to grayscale, but float 4. Delete. Swizzle. Float 1. I think this is going to be a swizzle. Float 1. Okay, there we go. So what I've done is I've basically thresholding that array of squares against the mosaic image of the mannequin. And so what I do is I compare them, and if one is greater than the other, I return a 0, and if not, I return a 1. And this is an exact duplicate of what happens in the hard mix mode, blend mode in Photoshop. A lot of people don't use the hard mix blend mode because they find it useless, but it's really good for this kind of thing. And if you'd like to see me do some stuff with the hard mix blend mode, basically the same thing except straight in Photoshop or in After Effects, you can do it. So you could do it in motion. I'll put a link to something you might want to check out. So let's see, what can we do here? Let's tiling and mosaic. So here's the mosaic. Here's that. So now float. Let's see, that goes to the lower one. So this one goes actually, is there a levels? Not here. Okay. There might actually be a levels in no, I guess not, or it would have shown up in that list, but there apparently is a list of library functions that you can also access. And let's see if I can find function nodes. So these things I think are also available within the when you're using a function. So let's see, what am I doing? I'm doing pixel processor, and so I'm just going to play with the luminosity for a second. So here's that. I'll set that to 1, and so this will go to the lower one, and this will go to up here, and this will go to over here. So all I'm doing is I'm adding a brightness knob to the mannequin. So if I turn that down, you can see it's changing the size of the squares. And the reason that they're squares and they of different sizes is because I started out with a pyramid, which is a stack of square shapes of varying sizes that builds in brightness. So that's why this works.